1972, a crack commando unit was sent to prison by a military court for a crime they didn't commit. These men promptly escaped from a maximum security stockade to the Los Angeles underground. Today, still wanted by the government, they survive as soldiers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire
Mr. Moore! Welcome to Mr. Moore's online flip classroom, and boy am I excited to be with you guys today because we are going to get everything that we have learned from the exponentials and logarithmic functions topic, and we are going to apply these to worded type questions or application questions or analysis type questions, whatever you want to call them. They're the hardest questions that we generally come across and that we've generally struggled with in the past. So we're going to look at how to break these down using some simple steps that can apply to all of these types of questions, regardless of what they actually say. So let's go through now and have a look at a little bit of an introduction on the must-do things that we have to go through and do in order to be able to answer these questions successfully. Let's check it out.
So in today's lesson we're going to look at how to attempt application type questions when dealing with exponential and logarithmic functions. Now, like any other type of application or analysis type question, there's a few steps that we must follow, and these are very similar to the ones that we've looked at in the past. And the steps are: firstly, you need to read the question carefully and make sure that you understand exactly what the question's asking. Now, if you're not sure, make sure you do seek some clarification from the teacher or something along those lines, because this will definitely help you out as you get better at these. Now, secondly, you need to highlight key information, because this is really important in drawing out all of the key things that you need to know when attempting these types of questions, and this will definitely help with your understanding as you read the question carefully, like I explained in step 1. Then thirdly, what you need to do is rewrite the key information in dot points. Now, this essentially just helps you in order to be able to determine what is the mathematics that we're actually trying to work with here in order to be able to answer this application type question. And finally, what you need to do is write an equation that represents what's actually occurring, because essentially you're going to be asked to do a whole bunch of things that will require you to solve and to simplify this equation. So it's really important that you do come up with an equation early on in the piece, because that will help you out throughout the rest of the questions related to this topic. And this equation will generally follow the rule y is equal to k times a to the power of x, where y is your dependent variable. That is generally what you're looking for. X is your independent variable. Now, this could generally be number of days and things like that. K is your initial value, so that is how much you start off with, or when x is equal to 0. And A is the amount that your initial value is increasing or decreasing by with every increase in your independent variable, or for example, number of days. So let's just have a look at a couple of ways that we could represent A. For example, if it says the value is doubling each time, we would write this as A is equal to 2. Whereas if it says that the value is increasing by 10% each time, well, we would write this as A is equal to 1.1, because you've got your 1 initially and then you're adding 0.1 for the 10% that it's increasing. And if it said that your initial value is decreasing by 30% each time, what we would write this as is A is equal to 0.7, because your initial value being 1, if it was just saying the same, A would be 1, but because it's decreasing by 30%, we're going to take away 30% from 1, so that will give us an A value of 0.7.
Awesome, guys. So I guess if we follow these 4 steps, at least we'll be on a path in the right direction. But it is extremely important that we do these 4 steps correctly, so that way we can set up what we need to know and what we do know in order to be able to answer the questions that are being asked. So let's go through now and have a look at a little bit of a worked example on how to attempt an analysis type question where the rule of the function is being given to us. Let's check it out.
Alright, so it's now time to have a look at an example where we're going to deal with an application type question for an exponential or a logarithmic function. So the very first thing that we need to do is read the question carefully, and this question says the price of gold, $p per ounce, can be modelled by the function p is equal to 400 plus 50 log 10 bracket 5t plus 1, where t is the number of days since 1980. Now the next thing it says is to highlight key information, so let's go through and do that. So the price of gold, $p per ounce. Right, so let's go price of gold. That's important because we need to know how much it is. So price of gold, $p per ounce. So p represents the number of dollars per ounce. Can be modelled by the function P is equal to 400 plus 50 log 10 5t plus 1. Functions are always important. And T is the number of years since 1980. Extremely important that, because it's determining when we actually start. Now the next thing to do is go through and rewrite key information in dot points. So let's go through and do that. The first thing that we need to write out is P is equal to dollars per ounce. The next thing that we need to write out is T is equal to the number of years. And of course our equation, and that is P is equal to 400 plus 50 log 10 bracket 5t plus 1, because that's going to help us out when actually working with the next bunch of questions that we've got regarding this information. Now the first question says find the price of gold per ounce in 1980. So what we're going to do is we're going to use our information that we've just written out here, because that's kind of like a plan of attack basically. So we're going to use that information in order to be able to answer these questions. So as I said, the first question says find the price of gold per ounce in 1980. So what that's telling us is basically the year that it started. Now it says in the question that it's the number of years since 1980, and we want to find out what the price of gold was in 1980. So that means the very first time that we started actually modeling this. So if it's the very initial amount, what we're looking for is when t is equal to 0, because the number of years since 1980 is actually going to be none. Now because we know that, what we can go through and do is substitute into our equation, because we know the number of years, we need to find out how much, which is what the question's saying, find the price of gold, so how much. So we need to find P is equal to question mark, because that's what we're looking for. So to go through and do this, we write out our formula. So we've got P is equal to 400 plus 50 log 10 to the 5t plus 1. Now we know that t is equal to 0, so let's go through and substitute that in now. So we get P is equal to 400 plus 50 log 10 bracket 5. Now instead of writing t, I'm going to write 0, so I go 0 plus 1, like so. Now I've just got to simplify it all and figure out what my answer is going to be. So I go P is equal to 400 plus 50 log 10. 5 times 0 is 0, plus 1 is just 1, so 1, like so. And therefore we get P is equal to 400 plus 50. Now log 10, 1, if you think back to when we're actually working with logs, any log base, doesn't matter what this is, to the 1 is equal to 0, so it's 50 times 0. So therefore we're going to have P is equal to 400, because when we do plus 50 times 0 we get 0, so it's going to be P is equal to $400. Now because it's a worded question, we should actually write a worded answer, and therefore we would say the initial cost of gold in 1980 was $400. Now for part B, it says find the price of gold in 2006. So we're going to once again use the information that we've come up with over here, that is P is equal to dollars per ounce, T is equal to number of years, and P is equal to the equation. What we're going to do is we're just going to figure out, well, how many years has it been since 1980 in 2006? Because that's what it's actually giving us, is the year. It's not giving us the price, because that's what we're looking for. So we need to find the number of years, and to do that we're just going to go T is equal to, well, how many years has it been? Well, it's going to be 2006 minus 1980, which is going to give us 26 years. Now because of that, we now know our t value is equal to 26. Do we know our p value? Well, no, we don't. That's a question mark. So we're going to need to find that by using the information that we've got. So to do that, we're just going to substitute into the formula. So you get p is equal to 400 plus 50 log 10 5t plus 1. Now all I need to do is just go through and substitute in my t is equal to 26. So I get p is equal to 400 plus 50 log 10 bracket 5, and now we're substituting t is 26, so we write 26 in brackets once again, and then we go plus 1, like so. Go through and simplify that a bit now, so you get 400 plus 50 log 10, 5 times 26 plus 1, well that's going to be 131, like so. And then if we go through and enter this into our calculator, what we're going to get is an answer of P is equal to $505 and 86 cents, so 505.86. So therefore we'll just write out the answer in a worded format, because it's given to us in worded format for the question. So we would say the cost of gold in 2006 is $505.86. Now the last question says, in what year will the price pass $555 per ounce? So what that's actually giving us is the price, because we know the price is going to be $550, But what we don't know is the number of years, so t is a question mark. So what we're going to do is use our information once again and substitute into the formula. That is, p is equal to 400 plus 50 log 10 bracket 5t plus 1. Now we know that p is equal to 550, so we're just going to substitute that in now. So you get 550 is equal to 400 plus 50 log 10 to the 5t plus 1. Now what we need to do is we need to look for t, so we'll just circle that one so we know what we're looking for, and we're just going to need to work backwards now. So to do that, we're going to subtract 400 off both sides, so you're going to get 150 is equal to 50 log 10 to the 5t plus 1. Then we're going to divide both sides by 50, so divide this by 50 and this by 50, which is going to get us 3 is equal to a log 10 to the 5t plus 1. Now as you can see, the t here is part of a log, so in order to undo a log, what we need to do is an exponential. So we're going to do 10 to the power of 3 and 10 to the log 10. They're going to cancel out, so we're going to be left with 10 to the power of 3 is 1000 is equal to 5t plus 1. Now what we need to do is just rearrange and solve for t, so you're just subtracting 1 gets us 999 is equal to 5t, and then divide both sides by 5 gets us t is equal to 199.8. So we know that 199.8 years after 1980, the price of gold will be $550 per ounce. So in order to find out what year exactly it is, what we need to do is go 1980 plus 199.8, and this gives us an approximate answer of the year 2180. So therefore the price of gold will be $550 per ounce in approximately the year 2180.